Hey there, boys and girls, moms and dads. Welcome back to this edition of Bill's Weather 101, the at-home game. So, what we are looking at today is the source of every bit of weather we talk about, the sun. It was something that when it comes out, as we're coming out of the winter season to the early part of spring, anytime we get some of that sun, it is truly, truly wonderful. It is the source of all life on Earth, but you notice we've got a little asterisk right there, because not too long ago they found out there are actually some life forms down at the bottom of the ocean that are by some of those heat vents, those smokers that they are down at the bottom of the Pacific and the Atlantic, that are not dependent on the sun at all. So we'll say most life on Earth, but it is certainly the creator of all weather that we see. You got to remember that the sun is heating up the atmosphere at different rates. Our atmosphere does not like things that are out of balance, and so the atmosphere is always trying to correct those imbalances. As for instance, when you talk about the sun up at the North Pole, where there isn't a whole lot, even though it'll be up there for the next 6 months, compared to what happens at the equator. It's cold at the North Pole, it's warm at the equator. Our atmosphere doesn't like that. So what happens is these big, gigantic air masses, warm air from the equator, starts heading up toward the North Pole, trying to make it warmer. Same time, cold air from the North Pole head down toward the equator, trying to make it cooler. Gigantic motions of air, started by that big glowing thing, are what we interpret as our changing weather, the cold fronts and the warm fronts, but it's all started by that. If the sun heated the Earth equally all the way around, weather would never change. My job gets really dull at that point. So luckily, it is always heating things differently, both on the planetary scale as well as in the micro scale. So let's talk more about, though, what is the sun here. At its core, 27 million degrees at the core. At the surface of the sun, well, it cools off to a mere 10,000 degrees, which is actually a little cooler than a lightning bolt. On March 26th, the day that we are recording this Bill's Weather 101 at home, the sun is 92.75 million miles away. We had perihelion back in January. That's when we are closest to the sun, and that occurs on January the 3rd when we are 0.4 million miles away. On July 4th, aphelion, we are more than 94.5 million miles away from the sun. Our orbit around the sun is not a circle. It is an ellipse, so it gets closer to the sun, then pulls away. And we are actually at the furthest point in the middle of our summertime. But we are hot because we're tilted toward the sun. And we talked about that with the seasons. So again, it changes distance, and it changes daily. There are some neat websites there that can tell you exactly how far away we are at any given time. Now, this big glowing ball of gas, which is nearly a perfect sphere, is made up of hydrogen and helium, and it's mostly hydrogen. What happens? It is so hot in the core of the sun that individual little hydrogen atoms, they are flying around. And when they fly around, they bang into each other. When they bang into each other, they're going so fast that they literally stick together. They fuse together. It's a process called nuclear fusion. When that happens, you go from two little individual hydrogen atoms to one atom of helium. And that's what's setting at the core of the sun. Now, it'll burn this fuel for quite a while. As the sun does age, it will begin to have to exhaust its hydrogen fuel, and it starts burning helium. So the helium starts cracking together. And there's a long chemical process. Well, it doesn't take long. It actually happens almost instantaneously, but it'll go from helium eventually to carbon. And so this is how elements are also made in the fires and the cores of what are stars and supernovas. By the way, when the light you see from the sun, it takes 8 minutes for it to reach the Earth. So if the sun were to somehow magically blink out now, we would know it for 8 minutes. So we've got that going for us, which is nice, but it's not going to blink out in the next 8 minutes. Its diameter, 864,000 miles across. You could roughly put about 100 and some Earths going across the face of the sun. But if you wanted to try and fill the sun, its volume, it would take 1.3 million Earths to fit inside the sun. By the way, it's also incredibly massive. And we're talking in terms of how much stuff is in there. That's why the gravitational effect is so great. And that mass is essentially, if you took the entire what's in the solar system, everything in the solar system, 99.98% of the mass of the solar system is right there. You know, you take out Mercury, Earth, Venus, Jupiter, all of Saturn, Uranus, Neptune, all of those, it's minuscule compared to what goes on here. By the way, there is something that's also called the heliosphere. It's essentially the sun's area of influence. And it goes out well past the orbit of Pluto. It goes past the Oort cloud where the comets reside, and it gets out into the boundaries called the heliopause, where interstellar space is. Man has sent two things out beyond the heliopause, the Voyager 1 and the Voyager 2 spacecraft. Over the last 10 years, both have gone now into interstellar space. And finally, the sun is 5 billion years old. It's not going to run out of fuel, though, anytime soon. It's a middle-aged star. Now, we're not saying that it's going to go out and buy a convertible or anything here soon. What we're saying, though, is that you don't have to worry about the sun going anywhere. It will be around in this basic state for about another 5 billion years. We threw in some other fun facts if you check the story that goes along with this video, along here at Bill's Weather 101 at home. But again, we really want to thank you for tuning into today's episode. We'll continue to bring these to you as we're all learning from